focus on the adoption case for IITA legumes and how we had come far using the enterprise breeding system. Just a bit of background. IITA is International Institute of Tropical Agriculture. We are based in Africa with a mandate on tropical crops, with research on maize, cassava, yam, bananas, and of course the legumes, cowpea and soybean. And of late, we have also had the mandate to work on bambara groundnut, taro, and other tree crops like coffee and cocoa. We have global partnerships with other institutions, CGI centers, and other private sectors across the globe. But this presentation, the focus is on legumes, cowpea and soybean being the pillars for nutrition and income for sustainable farming as well. Because these legumes, we all know, are a great source of nutrition and also of great source of income for our farmers, and also provide cover crop as a cover crop and nitrogen fixation for many purposes, and then for other sustainable farming practices. But however, there's a great challenge with all breeding programs, not limited to the legumes. Some of them has to do with yields and how we improve yields in farmers' fields, not only in our breeding programs, but across the farmers' fields in the reflection. If you look at the graph on my right here, you can see that in terms of soybean average yield from the period here, in Africa, we have Nigeria, Uganda, Malawi, and South Africa is the only one that is doing better here, over 1.5 tons or around that. The rest are below 1.5 tons per hectare, whereas in the US and Brazil, they are doing much better in terms of the production yields. Yeah, so a lot of challenges comes into that. One of them also has to do with data, how to combine this data from different sources, phenotypic, pedigree, and even metadata, to be able to analyze and come out with better estimation of genetic gains across the farmer fields. And with this, it requires a lot of complex tools like enterprise breeding system to be able to manage all these data sets from the various sources and to be able to estimate better genetic gains. And EBS was adopted by the cowpea and soybean breeding programs of IITA. And they had a number of reasons why they adopted the EBS. One of them was the complexity and quality of issues in breeding pipelines, which I just mentioned, how to combine all these data sources from different various platforms and combine them to make good decisions, as well as the quality issues. Also the need for real-time collaboration across the teams and locations. They work with other partners across and they share trials. Getting the real back is an issue. Sometimes they get them in Excel sheet. Sometimes they don't even get them. So with a system like EBS, what Michael just showed, we can share the system with them and they collect the data, send back direct to the system. We don't need to ask them to send files and send other means to us. Also, EBS also provide a robust seed inventory management system for the legumes. Unlike other systems, this was a very good reason why they chose it, that EBS has a very robust system that they can manage their seed quantities and transfer seed between programs and partners. Also, data privacy, Marco has just talked about that. In terms of data privacy and access, it's a security concern for most breeding programs and how to share data among them. So we have implemented what we call RBAC. Marco mentioned that role-based access control, where our users can share data and still have limitation, who can see what, who cannot access what within the breeding programs that they have. Comprehensive built-in print-out manager, printing labels, field tags, printing seed envelopes, and printing other kind of reports from the breeding program is a concern. And having a system that's able to do all this within one centralized dashboard is of great importance, and they chose that. Also, the system is very easy to use. It's lighter compared to that system, so you can work better in other low bandwidth areas, which the programs operate. There's a dedicated 24/7 global user support for EBS, great resource in terms of documentation, in terms of video tutorials, user guides, that can be accessed directly from the system. You don't need to go out and come back. If you're doing something, you have a challenge, you can always go there. So that was the system. Above all this, EBS is CGI endorsed system. It's preferred by the CGI as the breeding system of choice. And these are some of the reason why they choose that. There are so many domains in here, you can see the features in there. Time will not allow us to touch all this, yes. But we see EBS as a tool that is transforming breeding programs in terms of smarter breeding decision making. So all the objectives that we outlined during this migration project were just to enhance the data management practice within the legumes program in IITA, as we had so many data sources shared, sitting in people's breeders' computers, some not complete even in the BMS that they were. So we had come out with a better way to enhance this by moving the data into EBS as one of the objectives. And also to deliver better tools for readers in terms of accuracy, swiftness of decision making, having all these data in one centralized place was one of the objectives to have, as well as fostering collaboration and accessibility of the data in real time. This is becoming much important in every breeding program. Collaboration is becoming important, and we need to have this collaboration, and having the data in real time is important to make decisions faster and quicker. And also to streamline the whole process. Standardizing things is a must within the modern breeding project. We have to standardize things within and across breeding programs. And this was one of the moves in which we had. So we had taken this approach to deliver EBS to the legume program by putting them in a single, a multi-crop instance was rolled out for them, combining both cowpea and soybean data in the same system with features that are customizable to the product profiles, breeding pipelines, stage breed processes, and flexibility that the users can always configure. Even though there are different crops within the same instance, there's still that flexibility that the users can configure according to their needs and still use it. We also had this seamless connection between other tools like the Fieldbook and Bioflow for data capture and analysis. Was also implemented during this migration process, as well as standardizing germplasm traits, nomenclature, consistency, moving duplicate identification resolutions, and just making sure that the data that we are migrating was really of high quality in order to avoid that issues that we had earlier. Of course, user training is one of the priorities within the digital solutions team. We have a whole year for user training, and we see that we have to empower our users to be able to use the system. They should be confident enough to use the system and not fall back on us all the time if they have issues. So this was one of the last one we did before handing the system to them. In terms of migration, we had a migration pipeline that involves both manual and or semi-automated and automated process. With the semi-automated, we had the data managers from the breeding programs having to complete some migration templates and submit them through CSV files, and then we loaded them to EBS. The automated process we use, NIFA, is an Apache data flow automation system that was used to route the data from BMS to EBS directly. And of course, we were able to put all the primary data that they needed: programs, data, peoples, and the teams, the pipelines they're working on, the breeding stages and seasons, the germplasm traits, and other breeding locations and seed lots and packages. We also ensured that the data was of quality, high quality, before we move in there. We developed ask rates, and verification checks was in place, store procedures was in there, SQL to check all this and to merge the data that were duplicated and other issues that we had highlighted were resolved, just to ensure that the data we moved in was of high quality. There's one tool that is in EBS that is not highlighted in other tools that I've listened to so far. This is called the data collection terminal. In EBS, we don't just migrate the data or upload data to the system direct. There is a terminal or a system, a tool in there when the data is uploaded from Fieldbook app or through a file into the system that we use to check the quality of the data and also compute the traits that are computable before we load them there. We also have the chance there to even suppress data points that we felt are of maybe outliers or they are bad data points that we don't want them to be part of analysis. This tool is able to allow you to do that. So it was something that was of great importance to the breeding programs, as they have controlled the data and not just send data directly to the system. So this is the process in which we capture data using the Fieldbook app, of course, through Brappy, and then we can upload the data. And once the data is uploaded, it comes to the data collection terminal, and we can do all the review of the data there before we sync it. Data quality checking is important through a tool called the Phenotypic Data Manager, which can also be used to check the data even before analysis. And during analysis, yeah, you can do the multi-instance or single occurrence or multi-location analysis. And of course, we have the external tools that you can also link direct from EBS to, like the bioflow that Marco mentioned, to analyze your data as well. This is the data export, and it gives you the summary of what you are exporting from Fieldbook app, what is in there, what is missing, what are the variables that are in there before it goes to EBS. And it doesn't just sync directly to EBS like I said earlier. It gives you a transaction for you to review, quality check it, complete some trades, and then you can now sync it to EBS. You will have the chance to also download it to your computer to even further view it, or you delete the transaction if you feel like it was a wrongly uploaded data set. This is a data terminal that we have. It tells you data that has been uploaded. The one that is showing in blue here is just recently uploaded, hasn't been committed yet. It tells you the number of data points that are in there, who uploaded it, when it was uploaded, and you have the chance to review the data set before you sync it to the database. And then there is another review tab that's called the data summary view, which gives you a summary of your data set you are uploading to the system before you even sync it to the database. So you see how many data points are in there per trade, which ones are missing, which ones are invalid, and you see the averages and the base statistics of the data. And also you can see the trades that are computable from this data review terminal here. There are so many formulas that are automatically generated from the system. You don't need to compute this yourself. The system automatically does that based on the dependent variables that you have uploaded. And you have several formulas that can be computed for one trade. You have to choose one, and the system does it for you based on that. If you look at the last two here, this is about moisture using 15.5% computable, and the other one is 12.5% computable. So it's the you have to choose. Some reading programs will use 15.5, some will use 12.5. And this is how the plot view is like. Uploaded, you have a view to see the data points that are uploaded. Those that are green are within. If it's any issue in there, like the invalid one you are showing here is red, and it tells you that maybe it's outside your range. You can go back and look at it. You can suppress it if you don't want it to be part of a data set for now. You can also even override the data set that you've uploaded. And during the overriding, it shows you which one is changing. The ones that are highlighted in yellow over here is the new one that have been updated over the ones that are in black here. So it gives you a complete view of your data and what you are doing with your data. This is missing in most systems, and readers actually like this. They want to have a control of the data sets. In terms of user training, which I said we have a whole unit dedicated for training. EBS, we ensure that our users are well trained, confident to use the system before we hand over the system to them. And we have all the tools in the core building tools here, from concepts and overview of EBS, navigating around the system, creating a management list, sharing the list, and with other collaborators and partners, as well as seed inventory management and all the other tools that you can think of in the building program as part of the core building tools. This was a training session conducted in Kano for the CalP team last year. And this was also another training session for the Serbian team in Lusaka, Zambia, conducted last year on all the core building tools of EBS. Again, I already talked about EBS and bioflow. These tools are, actually working together, and they are all CGI endorsed tools. So we work together with the EBS and bioflow tools, training our leaders how to use these two tools together, how to be able to pull data from EBS to bioflow to analyze. And this was a training we conducted in Ibadan last year for building programs, not only the legumes, but also even the other building programs, because bioflow is open to all users. So we wanted to show them how to pull the data from EBS to bioflow for analysis. Some results through this process, we have seen that there's a standardization and harmonization of data between within the building programs in there. We have complete data now. Metadata is about the planting date, harvest date, the management practices, the fertilizer application, whatever is applied to that trial. This was completely missing in most of the trials in the previous ones we migrated. But with EBS, there's a system in there that allows you to even upload it and update things in bulk. One of the things that makes it easy is how to update things in bulk. Just apply the same amendment and apply it to all of that. Most systems you have to do it one by one. And with EBS, the bulk update of things is very important. And even you can do it within Excel file and upload, and you have the data very complete. So this was another great thing that they found that there's been improvement in the whole data flow, phenotypic data, and this is actually going to improve our decision making. Data quality has improved, like I said. We have checked all the quality issues before moving them. We've removed the duplicates and standardized entries and processes within the breeding programs. Data is now centralized and accessible. Formerly, it was spread through other users and people, its computers, and even those that was in DMS did not have complete data sets. Also, there's real-time collaboration. The EBS is stronger, it's proven to be stronger and resilient in low bandwidth areas. And users are actually seeing that. With EBS, whatever you say, whatever you do is automatically saved. You don't need to worry about losing your data or whatever stage. Whatever you do, at each point is saved, and you can continue from that, even if there's a breakout of internet. In terms of impact and broader implications, these are early days yet, but we can already see great efficiency and better data that within that will get us this so far for cowpea and soybean, and we're expecting better varieties using this data. We expect more resilient cowpea and soybean varieties meeting small farmers' needs using this complete data set that we are gathering for future use and analytics. EBS benefit goes beyond just legumes. It's a scalable solution for other crops and programs. We have developed pipelines for migrating data from BMS to EBS, and these pipelines can actually be used by any program that's willing to move from BMS to EBS easily. Marco mentioned that there's a second version that we're improving, but the first version it can even be used to just little tweaks, and then we can get data within days to EBS. So EBS is not just a technology or about data, it is our changing life. That's how we see, and we see that EBS has a greater future to modernize our breeding programs. Lessons learned during this program, process, user feedback was critical. We had what we call subject matter experts that we have source information from. We have contacted the breeders, technicians, data managers, and giving all this information from them actually helped in customizing the systems for their better use. Also, effective training methods were employed, and then to a wide adoption of the EBS tool because of better training that we give to the users. We have a dedicated responsive support desk that is responsible for 24-hour service and support to our users, and this is boosting their confidence and satisfaction of the use of the EBS. Of course, we have available resources within the system, video tutorials, user guides, documentation, release notes. All is available within the EBS system as a great point of reference for our users, and users don't have to go anywhere to reference them. Within the system, they can have a link to all this. Next steps, we need to conduct refresher trainings, continuous improvement of EBS based on our user feedback. We have to also to bring along our NAS partners, national research programs, as we are collaborating in this research work. Also, we need to build more partnerships to strengthen interoperability with other breeding tools. Marco has already outlined the roadmap for that. And beyond Bioflow, beyond Facebook app, beyond Igua, all other tools that we can think of related to breeding, we want to pull them here. We don't want to work in isolation. And then, of course, we are also trying to scale to other crops within IITA. Cassava, yam, and bananas are IITA managed crops as well. So the legumes and maize are already in EBS. So we are scaling to other crops of IITA. EBS, in conclusion, is a scalable and adaptable solution for modern breeding challenges and needs. It is easy to use, it's powerful, it's interoperable, it's configurable, it's field ready. We have a dedicated global user support, and it's also network building support for collaboration. So I welcome all of you to join us in EBS, to use EBS to transform our breeding programs. You can visit us through our website here, ebs.excellenceinbreeding.org. And for our resources in terms of video tutorials, in terms of user guides, you can also scan this, or you visit through this tinyurl.com/user resources. We also want people to try and use EBS, so you can request our demo access, and then by scanning this, just fill in the small details about you, your breeding program, and then you can invite us to come and give you a demonstration of the system. And we can even put your data there, create a program for you, and you test the system by yourself, and you can make your own informed decision to join EBS. We see EBS as a tool to transform our breeding programs. So these were the people that contributed to this migration program project of IITA legumes to the EBS team. We thank the leadership of the BR, the resources team, the digital resources leadership team, IITA head of breeding, the legume breeding teams, EBS engineering team, and of course our digital solutions that support the users of EBS. Thank you.